Okay, so we're gonna do numbers 1, 2, 3, and 4 first. So here we have the options for the elements, and then we have some descriptions. We have 4 descriptions. So I want you guys to take about a minute and a half. You can work with the person next to you. See if you guys can figure out which of these 5 elements matches these descriptions, okay? You will only use them once each. You're not gonna use them multiple times. Okay, so take about 2 minutes. Go ahead and do that. If you guys want to like jot down a quick explanation to why you think that is, it's kind of a good way for you guys to reinforce what you learned. But go ahead and do that. Practice book 3. It's the Princeton Review. Okay, maybe about 30 more seconds to finish that up.
Is there a reason why the air doesn't blow up whenever you like?
Yes, and we're gonna explain that in a sec too. Good tangent. Yeah, I'll talk about that. I'll address that. Yeah, because oxygen is very flammable, super flammable.
Does anyone remember the show Happy Tree? Yeah. Slice
Alrighty, you guys ready to go?
Yes.
Okay, let's go with number 1. Now, number 1, Mr. Pepik mentioned that last time. What is the most electronegative element? Yeah, fluorine. Okay, the reason why it is fluorine is because if you go to the periodic table, okay, now we know that the pattern is as you go up and to the right, it gets more electronegative, right? And so it's it's natural to think, oh, helium or neon are going to be the most electronegative. But if you guys remember, neon is a loner. Okay, neon is like me, doesn't want to hang out with anybody, doesn't want to react with anything. And so it's not going to be electronegative because it doesn't connect with anything. So fluorine is actually the most electronegative, element. And if you got that wrong, you guys just think of F. I got it wrong. Fluorine. Okay, so fluorine is the most electronegative element. Okay, number 2, we didn't talk about it much in this class, but you guys might know this. Does anyone know which isotope, which element we use to measure age of archaeological artifacts? Yeah, Molly. Yeah, carbon. That's why if you guys might have heard this in history class, but carbon dating, right? Carbon-13 dating. We usually use carbon. All right, number 3 was a little bit tricky because what we need to do is we need to draw the energy levels for this. And so we have to do 1s, we have to do 2s, we have to do 2p, and that's what all of these elements, the highest energy level. Now we said we always fill bottom up, and we also need to pair them. We have to fill in the empty orbitals before we start pairing them up. So if you guys take a look at carbon, how many electrons does carbon have? 6. So we go 1, 2, 3, 4, 5. But remember, we need to fill in the empty ones, 6. So is carbon completely paired up? No, right? We got 2 that are not paired up. We go nitrogen. Nitrogen just has 1 more, right? So nitrogen 7. So we need to fill in the empty one first. Is nitrogen all paired up? No, because these 3 don't have a pair. We go to oxygen. Oxygen pairs up this one, but we still have 2 that are not paired up. Fluorine, 1 more. Neon, no. So neon is the only one that is completely paired up. So that one was a little bit tricky. But if you guys can either answer this problem by drawing the orbitals, the subshells, or you can just recognize, hey, the only one that has a complete shell, right, is neon. Okay, so we did fluorine, yeah, noble gas. We did carbon, we did neon. Now we have nitrogen and oxygen. So Both of them are diatomic gases. So in nature, they're usually found as N2 and O2. But which one is the one that makes up most of the atmosphere? Who thinks it's oxygen? Who thinks it's nitrogen? Yeah, I actually mentioned it was nitrogen beginning of the year, but it is nitrogen. About 70% of the atmosphere is nitrogen, which is why, if you light a, match, it doesn't blow up the entire, atmosphere. It uses the oxygen around it, but it doesn't blow everything up. Fun fact, oxygen is very oxidizing, so it actually burns things. It all chemically destroys it. So if we did have a lot of oxygen in the atmosphere, it would kill us very, very quickly. Actually, the greatest mass extinction, they call it the Great Dying, where like 99.9% of every living thing died, was because plants made too much oxygen, and then it killed everything. Okay, can you bring them in and I'll tell you what to do next.
So killing trees is good? Yes.
No, we still need oxygen, but not too much, yeah. Yeah, so when there is a lot of oxygen in the atmosphere, it makes insects very, very big. So right after the Great Dying, the things that survived, like dragonflies were the size of like eagles. And they actually have seen this in labs where they put insects in oxygen-rich environments, and then the bugs just get bigger and bigger and bigger. So anyway, let us move on. Yeah. I don't know. All right, let's look at 5 through 7. Okay, so a little bit more of the same types of questions. I'll give you guys maybe a minute and a half to do these ones as well, and then we'll go over them in just a sec together. Morning. Yes, so I hope you ladies to your song. No.
Elaine, are you taking a test? You need help? Which one? Test. Let's use it semiconductors. Which one of those they use for computers? Come on. You probably didn't know what a semiconductor was. Pretty concentrated. How great. Very, very smart.
Alrighty, you guys ready to go? Are you guys ready to go? Okay, so semiconductors are things that we put in computer chips. Anyone know?
Copper.
Not copper, not silver. Yeah, silicon. Yes. Okay, B. Okay, number 6. This element is liquid at room temperature. Yeah, mercury. Yes, good. I actually mentioned this. Yes, I did. And then after oxygen, this is the most common element in Earth's crust. It's actually silicon. Yeah, so this one, there was a repeat. Yeah, it's about 26%. Okay, so those are just some information you guys might need in just about these elements. Nothing too fancy. You probably won't have questions like this on the AP test except this one about mercury, but it seems like everyone got that one right. So, okay, now let's do some actual chem questions. Okay, number 8. Okay, what is the most likely ground electron configuration for sodium, a sodium ion in its ground state? Okay, so go ahead and try it. Sorry, I will move this. Okay, make sure you're careful of the terms, okay? Give you guys about a minute to do this. Again, I do want to remind you guys that for the AP test, you have 90 minutes to do 60 MCQ questions. So you have about a minute, minute and a half to do each one. So you got to do these real quick. So I'm gonna give you guys a minute for this one. Yeah. Oh yeah, ladies, it doesn't have to be perfectly 25, just around 25 is good.
It has to be perfect.
It does not have to be perfect. We're using it as an excess reactant. Huh? It's very corrosive. It'll agitate your body tissue. Make sure you don't pour it back into the original container. Yeah, just making sure. All right, you guys ready to go?
Yeah.
Okay, so we got a sodium ion, and so if we take a look at let's look at regular sodium. Regular sodium is in the 3rd row. So what's going to be the final subshell? Yeah, tree what? Yeah, 3s1. Good. Okay, which means that we have 1s2, 2s2, 2p6, and 3s1. This is the configuration for regular sodium. Okay. Now, sodium, what does sodium ion want to do? It wants to get rid of an electron. So it's going to get rid of the final electron. So it's going to get rid of the electron in a 3s shell. So sodium ion will have electron configuration of this right here. It's going to be the same thing as neon because it's going to want to get rid of one electron. So it is going to be B. Yes, it is going to be B. All right. Any questions about that one? Make sense? Okay. All right, so I'm gonna leave that up there if you guys are copying it down, but let's try number 9 next. Again, I'll give you guys a minute to do this. Again, not a lot of time to read, but which of the following statements is true regarding sodium and chlorine? If it goes over a bit, it's fine. It doesn't have to be accurate. It's just an excess reactant. Yeah. So if you go to like 30, that's fine.
For number 9, does it mean sodium and chlorine when it's
You tell me. I'm not gonna be there during the test to tell you. I will not. No. I'm gonna have a sign that says, I hope you fail.
No, but here's the thing. It'll ignite our competitive spirits.
Yeah. It's reverse psychology.
Exactly.
I should put a sign outside the AP test center saying C's get degrees.
Yes.
All right, you guys ready to go?
Yes.
Okay, so hopefully this wasn't too bad. Because what you can do is that you can actually go through these options and just get rid of the ones if one of the statements is not true. Okay. So first statement A, sodium has a greater electronegative. Okay, that's not true, right? We know chlorine, because it is further to the right, is going to have a greater electronegativity. Okay, sodium has a larger first ionization energy. So ionization energy is when you take away an electron. So sodium we know has 1 valence electron. Chlorine we know has 7. So what does sodium want to do with the electrons? Does it want to gain or lose? So it wants to lose. Chlorine doesn't want to gain or lose. Gain. So is sodium gonna be harder to take the electron from? No, it's gonna be easier because it wants to get rid of it. Yeah, see, the language gets really tricky. So chlorine has a greater first ionization energy, so this is incorrect. We go to C. Chlorine has a larger atomic radius. Is chlorine bigger than sodium? No, it's not. Okay. Chlorine has a greater electronegativity. Yes. So there we go. We get the correct answer. And then if we look here, same thing, larger atomic radius. So we know that E is also incorrect as well. Yeah, what's up, great? Atomic radius is the size, how big. And remember the what is it? The pattern is as you go to the left and you go down, it's gonna get bigger. Yeah. So yeah, the hardest part is just the wording and doing it quickly. That's what's tough. Yeah. Alrighty, you guys ready to move on? Okay, number 10. I'm gonna give you guys a minute and a half to do this one. Which of the quantum numbers NL, ML, and MS for the valence electron in potassium in its ground state? You guys might not even remember this.
I don't. I'll be real. I don't. I like that.
So start with the N. N tells you which shell it's in. L is what subshell it's in. You guys might not remember.
You have a higher chance for the little ones than the other.
Yeah, I think C is slightly highest.
Nice.
All right. Are you guys lost?
No.
No? Okay. I'll give you guys 20 more seconds.
Because we can immediately, like, for MS, we can immediately eliminate all the 1/2 we don't need to worry about that.
Yes, that's true.
So then because it's an L. What is that face you're
Hmm.
I want to take a picture of you.
Please don't. I don't consent. Okay, let's go over this. So we're looking at potassium. So we know that N, or we should know N, is always the shell. So if we look at K, how many shells does K have? 4. So automatically we should know that for potassium, we cannot have an N number of 3 because it has 4 shells. Okay, so far so good? Okay, so we don't look at the 4s anymore. Instead, we need to look at the L value, which is going to be the subshell. Now, we know that for the subshells, we usually use letters, right? We use S, P, D, right? We're not going to go to F because there's no F here. But S, does anyone remember what value S is? 0. Good. S is 0. Genius. So that only gives us one answer.
Holy shit, I got it right.
Watch your language.
Holy crap, I got it right.
Watch your lane.
All right. Any questions? Yeah, and so yeah, you could have picked C using Josh's method of always pick C. And that's also Mr. O's method. C's get degrees. You pick C, you get a degree. All right. I'm not that funny. Okay, let's move on. 11. Okay, which of the following elements is diamagnetic? I didn't talk about this in class, but it was in your reading. So this shows that nobody does the readings.
I did the reading.
Nobody here reads. I know.
Right?
Nobody, yeah, usually unit 1, maybe unit 2, and then nobody reads no more. Okay, so let's go over what diamagnetic means. Okay, diamagnetic basically means that if we take a look at the subshells, the electrons are going to be split up. Okay, so we know that we start with the 1s, and then we go to 2s, and then we go to 2p, right? 2p is 3. Now, if we take a look at hydrogen, we know hydrogen has only 1. Okay, and then for lithium, we're going to, actually, I'll just give you the answer because it'll be easier to describe that way. Okay, the answer is going to be C, beryllium. Okay, yeah, C, again, C's get degrees. Okay, now beryllium's electron configuration looks like this. Okay, we have 2 complete orbitals in the 1s and the 2s subshells, right? 1s and 2s are complete. Okay. Now, that's what diamagnetic means. Diamagnetic basically means that a subshell, the 2 subshells have to be complete. Okay, that's basically what it means. If you look at Hund's rule, if you guys go back to the reading, Hund's rule is gonna allow you to figure that out. Yeah. Yes, it does. And you guys probably don't remember these either, all these rules.
I know that you see.
So they'll actually never ask you 12 on the AP test, so we're going to skip that because they're never going to ask you a question to remember the rules. Okay, instead, we'll go to 15, just so I don't have to scroll down yet. Let's go to 15. Which of the following ions has the smallest atomic radius? Okay, so we're doing 15 right now. Which of the following has the smallest atomic radius? Now, you guys might need to draw some Lewis structures, shell models, to help you guys figure it out, okay? Or just do that chart thing I taught you guys last time. All right, you guys ready to go? Okay, let's go over this problem. Okay, so what we're gonna do first is we are going to take a look at the number of shells because that's the most important thing when it comes to atomic radius. Okay, so how many shells does O2 have? 2, yeah, because it's gonna fill up the second shell. What about F minus? 2. What about Na plus? So Na plus, if we look at sodium, sodium has 3, but if I get rid of an electron, it's going to have 2. So Na plus has 2. Okay, next we go to magnesium. Same thing. Magnesium loses 2. How many shells will it have? 2. And what about aluminum? 2. Okay, so shells don't help us at all. Okay, so what we need to look at now are going to be the protons, because if you guys remember, the more protons there are in the center of the atom, it's gonna pull the electrons in, right? So out of these, whichever one has the most protons will be the one that is smallest. Okay, so which one of these has most protons? Yeah, aluminum. So aluminum is going to be the smallest. What do you mean all the number of electrons? Yeah, I think they all have the same number of electrons. Yeah, they all have the same. So literally the only thing that helps is combining the shells and the protons. Okay. All right, let's move on to the next one. Let's move on to 16. I want you guys to take a look at the quantum numbers, and I want you guys to tell me which one of these is not possible. Give you guys a minute to do that. You guys probably don't remember this. That C's get degrees. I'll let you guys know C's not the right answer. B as in bunnies.
What? Actually, no. Peruvian Spanish is really rhythmic, so you could. Peruvian. Peruvian Spanish.
Okay, let's move on, or let's go over the answer. So for the answer, the thing that you guys need to remember here is that the ML value always has to be smaller than the L value. Okay, ML always has to be smaller than the L value. Okay, if you guys don't remember, you guys need to review the quantum number rules. Okay, so if you guys take a look at this, is there an option where the ML is bigger than the L value? Yeah, B. So your answer is B.
Oh, I got that. I thought you were talking about 12. What? I got that correct?
Yes, congratulations. Okay, you had a 20% chance of getting it right. Actually 25 because I said C is not correct.
Actually, no. If you look at the previous one, they want to purposely give you the like a completely impossible problem, so then you just eliminate all what's there. And then
Sure, whatever. Okay, let's move on. Okay, we're going to take a look at 13 next. Which of the following is true of the alkali metal elements? Alkali. Oh. I'll give you guys 30 more seconds. All right, you guys ready to go? Okay, so if we take a look at alkali metals, do you guys remember where the alkali metals are on the periodic table? Anyone remember? Alkali. Alkalis are group 1. Everybody, so alkali is group 1. Group 2 is alkaline earth. So alkali is group 1. So if you guys didn't pick group 1, then sorry, you guys probably got this wrong. Okay, so group 1, the first column. So A is out because what oxidation state do they normally want to become? Yeah, they want to become +1. It's not 2, it's +1. Okay, do you guys even know what acid anhydrides are? So acid anhydrides are compounds that you form by removing water from an acid. And so You guys don't even know what that is, so we'll leave that blank because that could be an option, right? Do they form covalent bonds? No, because you remember what covalent bonds are?
Just like two different.
They share.
Yeah, it's gonna be non-metals. Okay, and group 1, they're metals. Okay, so we know that C is not the right answer. Okay, they are generally found in nature as compounds. So this is actually the correct answer because alkali metals, they are very reactive. Okay, they like to react with a lot of things. Alkali metals are interesting because if you throw them in water, they blow up. And so, yeah, that's fun. No, because the potassium in there it forms compounds with stuff in the banana. That's why bananas don't blow up.
So if we took apart a banana, would we just make it blow up?
No. No, a little different. Okay, and then this one we obviously know is incorrect. They have relatively large first ionization energy, which means it's hard to remove an electron, but we already know that they want to get rid of an electron. Okay, and so your options would have been these two, and which is why it's important to do the reading so you know what an acid anhydride is. We talked about this in the reactions unit with oxidation numbers and things like that. We talked about strong acids. Maybe. Okay. All right, let's go on to 14. Which of the following nuclei have 3 more neutrons than protons? This should be easy. Okay, which one of these elements has 3 more neutrons than protons? Should I scroll up a little, guys? Is it hard to see? Or zoom in? Zoom in? Okay, give me a sec. Zooming in. I don't. I told you, I'm making this up as I go. I'm a fraud. I'm not a chem teacher.
You're a quick street.
Fast. Women in STEM. We're not blowing nothing up, guys. Why do you guys always want to blow stuff up?
It's fun.
It's not fun. Actually, it is a lot of. It is a lot of fun. I'm recording this, so I'm not going to incriminate myself in any way. On the record, I am a law-abiding citizen. I've never done anything wrong. I've never lied in my whole life either.
Are we gonna pass this test?
Probably not. Okay, you guys ready to go? Okay, so let's just, the easiest way I think to do these problems is to go down the list and just figure out the protons. So how many protons does boron have? Dude, English, man. I don't speak Spanish. I told you I failed Spanish, guys. I passed AP Physics, AP Chem. I passed 12 APs and I failed Spanish 3. Okay, I took 12 APs, yeah. I went to a nerd school. Okay, so obviously this is not the correct answer because this number right here is protons plus neutrons. And so that means that B11 is going to have 7 neutrons, which is not going to be what we're looking for. We look at chlorine. How many protons does chlorine have?
17.
Yes. Huh?
Yeah, we had the same idea.
Sure, yeah. Okay, 17. And so obviously this is incorrect because how many neutrons does Cl37 have? How many neutrons? 20. Okay, how many protons does magnesium have?
Wait, what did I do the right answer? Because that's more neutrons than protons.
That's 3 more.
Yeah, so
Yeah,
it's a
17 plus
20
3 is
neutral.
right.
A 20 neutrals.
Hey, my bad, guys. Hey, you know what? You guys can come up here and teach the class next time. Yes, 20 neutrons. No, sorry. I totally forgot the point of the problem. I was looking for 3 neutrons. Sorry, guys.
Wait, what?
Okay, English is my second language, okay?
What's your first language?
No, English is my first language.
What's your second?
Korean. Thank you, ladies. You guys can just leave it on the cart and then just close up the cap. And then if you guys can wash the graduated cylinders, that'd be great.
Can you
Thank
say
you.
the next problem in Korean?
No. All right, let's move on to 15, or not 15. We already did 15. We're gonna move on to 17. You guys remember the formula?
Yes.
Okay, you're gonna have to look back at your notes. Okay, see if, or do you guys have your formula sheet? The AP Chem formula sheet?
Oh, yeah, I do.
Oh my goodness. Okay, make sure you guys always have, I'll pass it out if you guys don't have it.
This one, right?
Yes. What's up? Just regular water at the sink. Anyone who needs an AP Chem formula sheet? Okay, guys, I need you guys to hold on to this, to staple it to your forehead. To, I don't know, what, keep my eye. Get it tattooed on your arm.
Wow.
Anyone else on this side need the AP Chem formula sheet? All right, and so you guys have the formula sheet now, so I'm gonna give you guys 1.5 minutes to solve out this problem. Oh wait, sorry guys, it's not even on here.
Yeah, I was looking at.
My bad, guys. We'll skip this problem. This isn't gonna be on the test.
Wow.
All right, moving on. Okay, 18 won't be on there either. We'll do 20. I think 20 is a good one for ionization energy. So take a look at 20. I'll give you guys about 2.5 minutes to do this one, and then we'll go over it together.
Write your name on it. Do you want to sharpie your name on it? Yeah. Grab that with my grab button, too.
What are you doing?
No.
You know, green's my favorite color.
Is it really?
I feel like most Latinos have them.
My favorite's red.
Yeah, I hate that color.
It's the best color in the world. Better than green.
Those colors.
It's also on the opposites of the light spectrum.
We're pretty opposite.
We are. You're a girl, I'm a boy.
That's
All right, so process of elimination is probably the best way to do this one. All right, 30 more seconds, guys. I know this one's kind of hard to read just because there's so many numbers close to each other. A lot. You know what's a really hard tongue twister? Say toy boat really fast 10 times. It's hard, huh? It's impossible. Faster, dude. It's hard to say it normally too. You sound deficient.
wait, you're talking
No, tongue twister. Say toy boat really fast 10 times. Yeah, it's hard, dude.
I could say that's not.
All right, let's do this one, guys. So if we draw a picture of silicon, we know that silicon is going to have 3 shells, and how many electrons in the valence shell? 4, yeah, because it's in the 4th box in the 3rd row. Okay, so silicon is going to have 4 valence electrons. Now, when we talk about ionization energy, when does the ionization energy have the highest jump between numbers? Yeah, as we go to the inside shell, right? So where will we expect to have the biggest jump in ionization energies? So after it loses its shell, which means that this is I1, I2, I3, I4. So the biggest jump that we should see is in between I4 and I5, because I5 is going to be really big, right? Because once we do I4, we're getting rid of the outside shell, and I5, which is when we take away the first inside electron, that's when there's going to be the biggest jump. So if we take a look at this, let's just take a look at the numbers. Where's the biggest jump for A? Yeah, 1 and 2, right? So we know A is not going to be correct. Where's the biggest jump for B? Yeah, 2 and 3, which we know is not correct. The next one, where's the biggest jump? 3 and 4, which is incorrect. And then here we should get the correct answer where it's 4 to 5 is the biggest one. So D is the biggest one. And this is actually a pretty common type of question you'll see on the AP test, where they ask about ionization energies and the biggest jump. Like you guys said, it's when you go from the outside to the inside, that's where you'll see the biggest jump between ionization energies. Yeah.
Are we gonna ever get problems where it's gonna give us like the chart thing where it's like the ionization?
You might. I have personally never seen that where they give you the chart. The most common types are where they just ask you like, where's the biggest jump, or where you'll have to know where the biggest jump is. Okay, it's when you go into the inner shells. Okay, or they'll have you like compare two electrons, like compare magnesium's I2 with sodium's I2, which one? Yeah, something like that. Okay. All right. We're going to take a 7-minute break, and then we're going to come back and we're going to do the FRQs. Okay. So we're taking the break a little bit early today, but take about 7 minutes, go to the bathroom, get a stretch, and then we'll come back and do the FRQs. All righty, guys, let's get started with the FRQs. So I'm going to give you guys about 7 minutes to try this out. Try this out.
Wait, 7 minutes?
Yeah, 7 minutes to try to solve this FRQ. Now there are 4 different points. You need to address each of them. Now these are all 4 facts, and I need you guys to explain why these facts are true. Okay, so you need to justify your answer. And I know usually I don't ask you for complete sentences, but for the AP test, you're gonna want to write complete sentences. So let's practice doing that. Just take about 7 minutes. You can work with the person next to you if you really have to, but as practice, I recommend trying it on your own. Okay, 7 minutes, and then we'll go over them together. Yeah, what up?
We have, like, for all the previous tests, all the answer keys are online, right?
Yes. Yes.
Usually they have one problem that tries to go a different direction.
Yeah, and so for your exams that you take after you get them back, I do post the answer keys online. But if for whatever reason you need more explanation, or if I forget or something, just let me know and I'll be more than happy to go over it with you. Neutral, yes. Not. So make sure you guys that you guys talk about both parts of the question that are being asked. All right, let's move on to the last part. The last part is the first ionization energy of aluminum is lower than the first ionization energy of magnesium. Anyone want to take a shot at that? Yeah, Mel.
There's more electrons.
Exactly. Aluminum has more electrons in the valence shell. Electrons repel one another, making it easier to remove an electron.
Hello, Bruin students. Please remember, if you need to be screened, please report to the auditorium during lunchtime. Pathway Ambassador Club will be on Seaside today during lunch. Pathway Ambassadors, please meet on Seaside during lunch today. Thank you. Have a good lunch.
You too. All right, good. Any questions on the explanations? You guys good?
Wait, so it's, so we can only rate one sentence.
No, you can write more if you want to. It's good not to piss off the grader though. Because if you're writing like a 5-paragraph essay for each one of these, they're gonna get real pissed.
I'm just trying
Yeah.
to write down all the information that might.
Yeah, the key to good writing just in general is less is more. You want to be concise with your words. But yeah, if you want to go more sentences, that's totally fine.
Because it's not essay now, I was like, I don't want to write this.
Yeah, don't write, please don't write an essay. Yeah. Okay, we'll do one more and then we'll be done. We'll skip this one. We already know that. That one's pretty easy. Wow, we're pretty good, actually. We'll do this one. We'll do number 3. But we'll just do part A and then we'll be done for today, okay? I want you guys to explain the trend in electronegativity from P to S to Cl, okay? Just very briefly, we're just doing part A. And then after that, we'll be done for today. Is it really?
I mean,
Now that there's no math?
even if it's like, yeah, it's just the fact that it's fun to explain things rather than to actually like put so much work to get to that part of the plan. Absolutely. We're at that part where it is that's we're at verse 3.
Alrighty, just another minute, guys. Okay, let's go over the last one, guys, and then we'll be all done for the day. So we're going to explain the trend in electronegativity from phosphorus, sulfur to chlorine. Okay, so since it talks about all 3 of them, you need to mention all 3 of them in your answer, okay? So we're talking about the trend from phosphorus, sulfur to chlorine. Now, we already know the trend, right? What's the trend? As we go from P to S to Cl, does it get more electronegative or less electronegative? Yeah, it's going to get more electronegative. Okay, now we need to talk about all three of them as we talk about the electronegativity. So the first thing that you probably want to mention is that they have the same number of shells, right? Same number of shells. They all have how many shells? Yeah, 3 shells. Okay. However, how many protons does phosphorus have? 15. Sulfur is going to have 16 protons, and chlorine is going to have 17 protons. Now, what you want to do in your explanation is talk about how the more protons there are, the more they pull the electrons in towards the nucleus. Okay, and that's going to cause a greater attraction between the valence electrons and the nucleus, making it harder to take away the electrons, making the nucleus hold the electrons in tighter, something along those lines. Okay, that's it. Easy peasy. That is anticlimactic. You want a harder one to end it? Alrighty, guys. Well, good job today. I will post this onto YouTube, so if you guys want to review for the test, you can. Just a reminder that your exam is the next time that we meet, and then on Friday, that's when your homework number 8 is due. But it's a minimum day. We won't really be doing much. It'll just kind of be a relaxing day for you guys to just catch up on stuff if you guys need to. Okay. Yes.